Disc 3.
Let's now look at the departure from our FISO station. Our pilot has already booked out with the tower. This means he's provided details of the intended flight, including the call sign, destination, persons on board and fuel endurance, either by person or by telephone. Doing this reduces unnecessary transmissions and is a mandatory procedure at many airfields who will not take bookings out over the radio.
Ducks for information, Golf Golf Oscar Kilo Bravo.
Golf Golf Oscar Kilo Bravo, Duxford information, pass your message.
Golf Golf Oscar Kilo Bravo, parked east of the tower, request effort information and taxi.
Golf Kilo Bravo, runway 24, surface wind 260 degrees 10 knots, QNH 1024, taxi holding point Bravo.
Runway 24, QNH 1024, taxi holding point Bravo, Golf Kilo Bravo.
Golf Kilo Bravo, report ready for departure.
Wilco, Golf Kilo Bravo. Golf Kilo Bravo, ready for departure.
Golf Kilo Bravo, Cessna 172 turning base leg, runway 24, take off at your discretion, surface wind 250 degrees 9 knots.
Taking off, Golf Kilo Bravo. Golf Kilo Bravo, changing to Essex radar, 120.625.
Golf Kilo Bravo, roger. The following flight takes place to and from an airfield with a full air traffic control service, surrounded by an aerodrome traffic zone. Where just an ATZ is established around an aerodrome, the call sign used by the ground station will give you a clue as to the level of service to be expected. During your pre-flight planning, checking either the air pilot or Pooley's flight guide will give you the call sign of the ground station next to the appropriate frequency. Our example here has an approach and tower frequency notified. Inbound, we should make our first call to approach.
Cranfield approach, Golf Mike Echo Hotel Echo.
Golf Mike Echo Hotel Echo, Cranfield approach, pass your message.
Golf Mike Echo Hotel Echo, Saratoga, departed Elstree inbound to Cranfield, 8 miles south, altitude 2,000 feet, request join.
Golf Hotel Echo, join left base runway 22, report field in sight.
Join left base runway 22, Wilco, Golf Hotel Echo.
Golf Hotel Echo, the Cranfield weather.
Pass your message, Golf Hotel Echo.
Golf Hotel Echo, Cranfield at time 1320, wind 190 degrees 12 knots, visibility 8 kilometre, cloud scattered 3,000 feet, QNH 1002, QFE 996 millibars.
QNH 1002, QFE 996 millibars, Golf Hotel Echo. Field in sight, Golf Hotel Echo.
Golf Hotel Echo, contact Cranfield Tower 134.925.
Contact Cranfield Tower 134.925, Golf Hotel Echo.
Our pilot would then retune his radio to the appropriate frequency, listen out, and then establish two-way communication with the tower.
Cranfield Tower, Golf Mike Echo Hotel Echo.
Golf Mike Echo Hotel Echo, Cranfield Tower, join and report left base runway 22, QFE 996 millibars.
Join and report left base, runway 22, QFE 996 millibars, Wilco, Golf Mike Echo, Hotel Echo. Golf Mike Echo, Hotel Echo, left base.
Golf Hotel Echo, roger, report final runway 22. Number 2, following an AA5, 1 mile final.
Report final, number 2, runway 22, visual with the AA5, Golf Hotel Echo. Golf Hotel Echo, final.
Golf Hotel Echo, runway 22, cleared to land, surface wind 170 degrees, 8 knots.
Runway 22, cleared to land, Golf Hotel Echo.
Golf Hotel Echo, vacate right, taxi to grass parking, cross runway 18.
Vacate right, taxi to grass parking, cross runway 18, Golf Hotel Echo.
I'd like you to notice in that last exchange we have been given specific instruction to taxi over a crossing runway. If that instruction had not been given, we would have had to stop before the second runway and check with the tower as to whether we're allowed to continue across it. Let's listen to the departure. We'll assume the pilot has already booked out and listen to the ATIS broadcast.
Cranfield Tower, Golf Mike Echo, Hotel Echo.
Golf Mike Echo, Hotel Echo, Cranfield Tower, pass your message.
Golf Mike Echo, Hotel Echo, Saratoga, apron 5, information Zulu, QNH 1023, request taxi.
Golf Hotel Echo, taxi holding point Alpha 1, departure runway 22, cross runway 18.
Taxi holding point Alpha 1, departure runway 22, crossing runway 18, Golf Hotel Echo. Golf Hotel Echo, ready for departure.
Golf Hotel Echo, after the landing Seminole, line up runway 22.
After the landing Seminole, line up runway 22, Golf Hotel Echo.
Golf Hotel Echo, runway 22, cleared for takeoff, surface wind 280 degrees, 9 knots, report reaching altitude 2,000 feet.
Runway 22, clear for takeoff, Wilco, Golf Hotel Echo. Golf Hotel Echo, altitude 2,000 feet.
Golf Hotel Echo, contact Cranfield approach 122.850.
Roger, changing to Cranfield approach 122.850, Golf Hotel Echo.
Lastly, for this section's example flights, we'll look at airfield operations to and from an airfield situated within a control zone. Controlled airspace is established around major airports to provide a known environment for IFR operations to take place. The largest airports will have a Class A control zone, within which VFR operations are not permitted. Any flight not in compliance with the instrument flight rules would require a special VFR clearance in this case. Within other classes of control zone, VFR flight is allowed. The imaginary airport we will use for this example is in a Class D zone. It has ATIS, ground, tower and radar frequencies notified. Our pilot has already booked out for a local flight and has listened to the ATIS broadcast.
Denton Ground, Golf Mike, Oscar, Juliet Echo.
Golf Mike Oscar Juliet Echo Denton Ground. Pass your message.
Golf Mike Oscar Juliet Echo, PA28, the grass parking. Information Kilo, request taxi.
Golf Juliet Echo, taxi holding point Delta 1, runway 34, QNH 1023, Kilo current.
Taxi holding point Delta 1, runway 34, QNH 1023, Golf Juliet Echo.
Because we're leaving an airport within controlled airspace, an air traffic control clearance is required to fly within the zone. I'd like you to note that both the controller and the pilot use the aircraft's full call sign when the clearance is passed and read back. Golf Juliet Echo, zone clearance.
Golf Juliet Echo, passing message.
Golf Mike Oscar Juliet Echo, cleared to leave the Denton zone, VFR, not above altitude 2,000 feet, squawk 7033.
Clear to leave the Denton zone, VFR, not above altitude 2,000 feet, squawk 7033, Golf Mike Oscar Juliet Echo.
Golf Juliet Echo, read back correct, report ready for departure.
Bloque, Golf Juliet Echo. Golf Juliet Echo, ready for departure.
Golf Juliet Echo, contact Denton Tower 132.5.
Changing to Denton Tower 132.5, Golf Juliet Echo. Denton Tower, Golf Mike Oscar Juliet Echo.
Golf Mike Oscar Juliet Echo, Denton Tower. Are you ready for an immediate departure?
Affirm, Golf Mike Oscar Juliet Echo.
Golf Juliet Echo, runway 34, cleared immediate takeoff, surface wind 010, 12 knots.
Runway 34, cleared immediate takeoff, Golf Juliet Echo.
Golf Juliet Echo, contact Denton Radar 122.650.
Changing to Denton Radar 122.650, Golf Juliet Echo. Denton Radar, Golf Mike Oscar Juliet Echo.
Golf Mike Oscar Juliet Echo, Denton Radar, report leaving the zone.
Bloque, Golf Juliet Echo. Golf Juliet Echo, leaving the zone.
Golf Juliet Echo, roger, report ready for rejoin basic service.
Basic service, Bloque, Golf Juliet Echo.
When ready to return to the airport, our pilot should listen to the latest ATIS before requesting rejoin.
Denton Radar, Golf Mike Oscar Juliet Echo, inbound, information November.
Golf Mike Oscar Juliet Echo, Denton Radar, squawk 4651, QNH 1006. Information Oscar, current, no significant change. The instruction to squawk means that the pilot should set the stated code on the aircraft transponder. We will discuss the phraseology associated with the use of transponders shortly.
Squawk 4651, QNH 1006. Information Oscar, Golf Mike Oscar Juliet Echo.
Golf Mike Oscar Juliet Echo identified, basic service, cleared to enter the control zone VFR, not above altitude 2,000 feet, report airfield in sight.
Basic service, cleared to enter the control zone VFR, not above altitude 2,000 feet, Wilco, Golf Mike Oscar Juliet Echo. Golf Mike Oscar Juliet Echo, field in sight.
Golf Juliet Echo, join left base runway 34.
Join left base runway 34, Golf Juliet Echo.
Golf Juliet Echo, contact Denton Tower 132.5.
Changing to Denton Tower 132.5, Golf Juliet Echo. Denton Tower, Golf Mike Oscar Juliet Echo.
Golf Mike Oscar Juliet Echo, Denton Tower, report left base runway 34.
Wilco, Golf Mike Oscar Juliet Echo. Golf Mike Oscar Juliet Echo, and now left base.
Golf Juliet Echo, report final number 2, follow a Boeing 737, 2-mile final. Caution weight turbulence, recommended spacing 6 miles.
Report final number 2, visual with the Boeing 737, Golf Juliet Echo. Golf Juliet Echo, final.
Golf Juliet Echo, runway 34, continue approach.
Runway 34, continue approach, Golf Juliet Echo.
Golf Juliet Echo, cleared to land, surface wind 010 degrees, 5 knots.
Runway 34, cleared to land, Golf Juliet Echo.
Golf Juliet Echo, vacate right, hold Foxtrot 3, report runway vacated.
Vacate right, hold Foxtrot 3, Wilco, Golf Juliet Echo. Golf Juliet Echo, vacated.
Golf Juliet Echo, contact Denton ground 123.425.
Roger, contact Denton ground 123.425, Golf Juliet Echo. Denton ground, Golf Mike Oscar Juliet Echo, holding Foxtrot 3.
Golf Mike Oscar Juliet Echo, Denton ground, hold position. After an Airbus A320 passes left to right, taxi to grass parking.
After an A320 left to right, taxi to grass parking, Golf Mike Oscar Juliet Echo. Now, just a short section on special VFR operations. Special VFR clearances are only issued within control zones, usually at the request of the pilot. Special VFR is a concession offered by air traffic control, which allows an aircraft to operate within a control zone which is Class A, or in any other control zone in IMC or at night, without requiring compliance with the instrument flight rules. Instead, the pilot follows specific instructions issued by the controller. When flying on a special VFR clearance, the pilot has certain responsibilities, namely, he or she must comply with air traffic control instructions, is responsible for ensuring that his flight conditions enable him to remain clear of cloud and obstructions and determine his flight path with reference to the surface, is responsible for flying within the limitations of his license, is responsible for complying with the relevant low-flying restrictions of Rule 5 and 6. Although absolved from the 1,000-foot rule on a special VFR clearance, pilots must still observe the requirement to alight clear of a built-up area. And finally, is responsible for avoiding aerodrome traffic zones unless prior permission to enter has been obtained from an appropriate air traffic service unit. No separation will be provided between special VFR flights flying in notified areas or routes where an individual clearance is not required, or between aircraft using such areas or routes or other flights on special VFR clearances. Otherwise, standard separation is applied between special VFR flights and between special VFR and IFR flights. Special VFR aircraft are not normally given a specific height to fly. Controllers achieve vertical separation from higher traffic by requiring the special VFR flight to fly not above a specific level. A full flight plan is not necessary for a special VFR flight. However, brief details should be passed by the pilot, including the call sign, aircraft type and pilot's intentions, and, for inbound aircraft, an ETA for zone entry. On departure, special VFR flights will be given specific instructions in the clearance to leave the control zone.
Golf Alpha Juliet Golf Victor, leave the control zone, special VFR, via route November, not above altitude 2,000 feet, squawk, tree 445.
Roger, leave the control zone, special VFR, via route November, not above altitude 2,000 feet, squawk, tree 445, Golf Alpha Juliet Golf Victor.
Golf Victor, correct.
And let's listen to an example of a special VFR arrival.
Golf Mike Oscar, enter the control zone, special VFR, not above altitude 2,000 feet, via reporting point Tango, squawk, tree 445.
Roger, enter the control zone, special VFR, not above altitude 2,000 feet, via reporting point Tango, squawk, tree 445, Golf Mike Oscar, Whilst en route, a special VFR zone transit may be requested. The minimum details required by the controller and the communications exam are call sign, aircraft type and pilot intentions, and, for inbound aircraft, an ETA for zone entry. However, in practice, in today's mostly radar environment, the controller will usually want to hear the usual ADPAR details. We will now hear a special VFR zone transit. Denton radar, Golf Mike Juliet Delta Echo.
Golf Mike Juliet Delta Echo, Denton radar, pass your message.
Golf Mike Juliet Delta Echo, PA28 requests special VFR zone transit, startup and taxi, or prior to the aircraft commencing its final approach, but in sufficient time to ensure the safe operation of the aircraft. If the aerodrome has an ATIS facility, essential information may be added to the broadcast. Alternatively, the details may be passed by radio. Construction or maintenance work on or adjacent to the manoeuvring area, rough or broken surfaces on runways or taxiways, and whether the areas are marked or not. Snow and ice on runways. Larger airports may be able to measure and report the braking action in icy conditions. Water on runways. This is reported for each third of the runway and as either damp, wet, standing water, or flooded. Snowbanks or drifts adjacent to a runway or taxiway. Other temporary hazards including parked aircraft, aircraft engaged in engine ground running, and any bird activity. And finally, failure or irregular operation of approach aids or the aerodrome lighting system. In response to essential aerodrome information passed by ATC, it is sufficient just to say, Roger, and your call sign. Let's hear some examples.
Golf Hotel, caution work in progress on the main apron centreline.
Or
Modern Air 120, caution work in progress south side of taxiway Alpha.
Or
Golf Charlie Kilo, runway surface damp, wet.
Or
EC2 Tree Bravo Hotel, caution, approach lighting runway 26 unserviceable.
Or
Delta Oscar Hotel, caution as you pass a beam stand 3. Fokker 27 on your right has started engines.
Roger, Delta Oscar Hotel.
To conclude this unit, I would like to talk about the radio telephony procedures at unattended aerodromes and SafetyCom. The frequencies used at licensed aerodromes are published in the UK AIP, and all communication with a particular aerodrome must take place on its allocated frequency. Where no frequency is allocated, a common SafetyCom frequency is available to use, on which pilots may transmit their intentions to other aircraft that may be operating in the vicinity of the aerodrome. But more on SafetyCom shortly. Aircraft movements may sometimes take place outside the normal operating hours of air traffic services. In the interest of enhancing safety, pilots should broadcast their intentions on the promulgated frequency to other aircraft on the airfield or in the vicinity. All transmissions at unattended aerodromes should be addressed to the aerodrome name and the word traffic, for example, Bourne traffic. Unattended aerodrome reports are made at the discretion of the pilot. Therefore, a good lookout must be maintained, as not all aircraft may be monitoring the frequency or making broadcasts. The reports described below relate to a standard overhead join, which would allow the pilot to determine the runway in use and integrate with other traffic. However, specific joining and circuit procedures are prescribed for some aerodromes, and pilots should refer to the UK AIP or Pooley's Flight Guide to determine the precise procedure to be followed. We'll now hear some phraseology examples for unattended aerodromes. Taxiing.
Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, taxiing for runway 36.
When the aircraft is ready for departure.
Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, lining up for departure runway 36.
And on joining the circuit.
Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, 10 miles west, joining overhead. Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, overhead, joining for runway 36. Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, dead side, descending runway 36.
And we'll now hear the circuit calls.
Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, downwind, runway 36.
The pilot may report downwind right hand if that is applicable.
Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, base leg, runway 36. Fenland traffic, Golf Hotel, Bravo, Alpha Hotel, final, runway 36.
The transmissions for taxi, overhead, descending dead side and base leg are optional, but may be advisable depending upon the traffic situation. SafetyCom. SafetyCom is a common frequency introduced for use by aircraft in the vicinity of an airfield or landing site that does not have a notified VHF frequency for radio communications. The frequency is 135.475. SafetyCom is not an air traffic service and there is no associated ground station. SafetyCom is made available to assist pilots in avoiding potential collisions between arriving and departing traffic, and should be used only to broadcast the pilot's intentions. It is emphasised that SafetyCom should only be used at locations having no allocated ground frequency. If a particular frequency is notified for use at a particular aerodrome, it must be used for communication even outside normal operating hours. As SafetyCom is a single common frequency for many landing sites, the possibility of congestion and breakthrough exists. It is therefore important that your transmissions are concise and correct. Transmissions should only be made on safety comm when aircraft are below 2,000 feet above the aerodrome or location elevation, or below 1,000 feet above the promulgated circuit height. Transmissions must also only be made within 10 nautical miles of the aerodrome or intended landing site. Where an aerodrome or landing site lies within controlled airspace, pilots must first obtain a clearance to enter that airspace from the appropriate air traffic service unit.
Unit 3. En route procedures. Introduction. There are various levels of service available to en route aircraft. In this introduction, I will provide a general overview of each. I will start with the most sophisticated, radar services. Radar services comprise A. Separation of arriving, departing and en route traffic. B. Radar vectoring. C. Position information to assist in navigation. And D. Assistance to aircraft crossing controlled airspace. Within controlled airspace, classes A to E, a radar control service will be provided. Outside controlled airspace, classes F and G, a lower airspace radar service may be available, comprising either a deconfliction service or a traffic service, the former being more suitable for IFR operations, the latter for VFR. We will look at how we obtain radar services, their use and implications a little later. Where radar is not available, traffic must be separated either vertically or horizontally using either distance or time. This is known as a procedural service. It requires regular position reports from pilots to ensure that the traffic situation is up to date. The standard format for a position report is A. Aircraft call sign, P. Position, T. Time, L. Level, N. Next reporting point, and E. ETA for the next reporting point. APT LNE. You will be required to give position reports using this format during your RT practical examination. A basic service is available from all air traffic service units, providing pilots with data useful for the safe and efficient conduct of flights. Some units provide this service in addition to their other tasks, and some units are dedicated to providing basic service. In the UK, we have two dedicated units, London and Scottish Information. It should be noted that London and Scottish Information provide information only and have no control function. An alerting service is provided to notify appropriate organisations regarding aircraft in need of search and rescue aid. All air traffic service units automatically provide this service to any aircraft known to them. Let's look now at some general radar phraseology. We will begin with an overview of phraseology commonly used in communications between aircraft and all types of radar unit. Usually, the call sign suffix used by a unit is sufficient to determine its function. In a radar environment, all heading information given by the pilot or instructions issued by controllers are in degrees magnetic. The phrase "under radar control" will only be used when a radar control service is being provided, i.e. within controlled airspace. The word radar is a contraction of radio detection and ranging. Radar uses a high-frequency radio beam which will reflect from solid objects, such as your aircraft. The equipment is then able to determine from which direction the return has arrived, and the aircraft is detected. As the speed at which a radio signal travels is known, it is fairly simple for the range to be calculated. A target is then painted on the controller's screen in the appropriate position to represent an aircraft. This system is known as primary radar. When operating using primary radar, all the controller will have to represent your aircraft on the screen is a blip, which will look exactly the same as all the other blips. Before any type of radar or surveillance service is provided, the controller must identify the aircraft concerned. It is emphasized that the act of identifying an aircraft is not a service in itself, and a pilot should not assume that he is receiving a radar service, especially when flying outside controlled airspace, unless the controller specifically states that this is the case. To stress this point, controllers may use the phrase "for identification." There are 4 methods controllers use to achieve identification. A is the turn method. The aircraft's heading is ascertained, and after the track has been observed, the pilot is instructed to make a heading change of at least 30 degrees. B. Departing aircraft method. Correlation of a radar return with a known departure time. C. Position report method. Correlating a radar return with a report from the pilot that the aircraft is either over an exact reporting point, a radial and DME from a co-located VOR or DME, or over a visual reference point or prominent geographical location. The final method is using secondary surveillance radar information. That means transponder data. Let's hear an aircraft being identified using a turn.
Golf Mike Echo, report heading.
Heading 250 degrees, Golf Mike Echo.
Golf Mike Echo, for identification, turn left, heading 220 degrees.
Left, heading 220 degrees, Golf Mike Echo.
Golf Mike Echo identified 15 miles northeast of Luton, traffic service.
Traffic service, Golf Mike Echo. Or alternatively,
Golf Mike Echo, not identified, resume own navigation.
Wilco, Golf Mike Echo. You will be advised if the identification of your aircraft is lost, or about to be lost, and appropriate instructions given. For example,
Golf India Golf Oscar Romeo, radar identification lost due radar failure, resume your own navigation, basic service available from London Information 124.6.
Changing to London Information 124.6, Golf India Golf Oscar Romeo. Or
Modern Air 337 shortly leaving radar cover, radar service terminated, squawk 7000, report changing to en route frequency.
Squawk 7000, radar service terminated, changing to Birmingham approach 118.050, Modern Air 337.
Modern Air 337, roger.
Radar vectoring. A controller has complete freedom to instruct an aircraft to turn in any direction. However, when avoiding unknown traffic, the rules of the air will be observed if practicable. Aircraft may be given specific vectors to fly in order to establish lateral separation. The reason for requiring a particular vector to be maintained may or may not be given.
Speedbird 477, turn left, heading 120 degrees for separation.
Left heading 120 degrees, Speedbird 477. Sometimes, an aircraft's heading is ascertained and, once known, separation can be achieved by requiring the aircraft to continue on its existing heading.
Golf November Zulu, continue present heading, report that heading.
Heading 340 degrees, Golf November Zulu. Or, the controller may require an aircraft to fly a particular heading.
Shamrock 2 Tree Bravo, turn right heading 050 degrees, delaying action.
Right heading 050 degrees, Shamrock 2 Tree Bravo.
Golf Golf Romeo, heading 090 degrees.
Turning left heading 090 degrees, Golf Golf Romeo. Once vectoring is complete, the pilot will be given position information and, if necessary, appropriate instructions for being instructed to resume his own navigation. Here are some examples of the different ways this may be done.
Golf Hotel Hotel, resume own navigation, direct Bovingdon, position is 5 miles south of Luton.
Direct Bovingdon, Golf Hotel Hotel.
Golf Sierra Mike, resume own navigation, direct Bovingdon, track 220 degrees magnetic, range 12 miles.
Direct Bovingdon, Golf Sierra Mike.
Golf Mike Oscar, resume own navigation, position is 5 miles southwest of Bovingdon.
Wilco, Golf Mike Oscar.
Occasionally, an aircraft may be instructed to orbit, a complete turn of 360 degrees, usually for delaying purposes or to achieve the required spacing behind preceding traffic.
Golf Golf Hotel, delaying action, orbit left.
Orbit left, Golf Golf Hotel.
Sometimes this manoeuvre is simply referred to as a 360.
Golf Juliet Sierra, delaying action, make a 360-degree turn right.
360, turn right, Golf Juliet Sierra.
Traffic information and traffic avoidance. When a controller wants to alert you to traffic in your vicinity, the information will include the following: bearing from your aircraft in terms of the 12-hour clock code, distance from your aircraft in miles, direction in which the conflicting traffic is proceeding, level information when available. This may include unverified mode Charlie readouts of unknown aircraft, and the relative speed of the conflicting traffic or type of aircraft may be included if known. Its relative movement can be described by using one of the following terms as applicable: closing, converging, parallel, same direction, opposite direction, diverging, overtaking, crossing left to right, or crossing right to left. You may hear the phrase pop-up traffic used. This means that the traffic has suddenly appeared on the radar screen, perhaps climbing up from low level. We'll now listen to some examples of traffic information. Golf Sierra Yankee, unknown traffic, 2 o'clock, 4 miles, opposite direction, fast moving. Golf Charlie Kilo, unknown traffic, 11 o'clock, 3 miles, indicating 2,300 feet unverified. You should acknowledge the traffic information by advising the controller whether or not you can see the confliction. Suitable phrases are:
Looking, Golf Alpha Victor.
Or if you can already see the traffic,
Traffic in sight, Golf Alpha Victor.
or
Visual, Golf Alpha Victor.
We will discuss the services available from a radar unit shortly. For now, just appreciate that under a service known as a traffic service, traffic information is passed and the pilot decides whether any action is necessary to avoid the conflicting traffic. Under another service, traffic avoidance will be passed to the pilot. Here, the controller accepts the responsibility for deconflicting the traffic, and this is called a deconfliction service. It is also available to aircraft flying outside controlled airspace, and vectors may be offered or requested by the pilot. The pilot will be advised when the conflict no longer exists. For example, Golf Sierra Papa, unknown traffic, 2 o'clock, 4 miles, opposite direction, fast moving. If not sighted, turn left, heading 245 degrees.
Roger, turning left, heading 245 degrees, Golf Sierra Papa.
Or Modern Air 886, unknown traffic, 10 o'clock, range 8 miles, crossing left to right, no height information.
Modern Air 886, negative contact, request vectors.
Modern Air 886, deconfliction service, turn right, heading 045 degrees.
Deconfliction service, turning right, heading 045 degrees, Modern Air 886.
Modern Air 886, clear of traffic, resume own navigation, direct Barkway.
Direct Barkway, Modern Air 886.
The act of identification is made much more straightforward using secondary surveillance radar, SSR. We will now examine the phraseology associated with the use of transponders. Pilots should note that it is emphasised that assignment of a code does not mean that a radar service is being provided. SSR operating instructions are an item that you are required to read back. The instruction to squawk, followed by a 4-digit code, means set the code as specified on the transponder. In this example, we would dial 7041 and set the function selector to on. Golf Mike Oscar, squawk 7041.
Squawk 7041, Golf Mike Oscar.
Confirm squawk means check the code set on the transponder. You would check to make sure that the code is selected correctly and tell the controller the number selected. Golf Charlie Kilo, confirm squawk 0203.
Roger, Squawk 0203, Golf Charlie Kilo.
Reset means reselect the assigned code. You would physically select standby and then recycle all of the digits, returning the selector to the on position afterwards. Golf Sierra Mike, reset 3445.
Reset 3445, Golf Sierra Mike.
Squawk ident means operate the SPI feature. SPI stands for Special Position Identification and is more usually referred to as simply the ident button. Pushing this creates a signal which highlights your return on the controller's radar screen. Golf Bravo Hotel, squawk ident.
Squawk ident, Golf Bravo Hotel.
Squawk Mayday tells you should select the code used to indicate an emergency, which is 7700. Golf Alpha, squawk Mayday.
Squawk Mayday, Golf Alpha.
Squawk Standby means that you should move the transponder's selector to the standby position so that it's not actually transmitting. Golf Hotel Echo, squawk Standby.
Squawk Standby, Golf Hotel Echo.
Squawk Charlie is an instruction to set the transponder's function selector to the altitude reporting feature, normally labelled ALT, and referred to as Mode Charlie. Golf Echo Tango, squawk Charlie.
Squawk Charlie, Golf Echo Tango.
Not surprisingly, Stop Squawk Charlie means deselect pressure altitude reporting. This instruction would normally be given where there is a discrepancy between the Mode Charlie indication displayed on the radar and the level reported by the pilot. Controllers are able to take the Mode Charlie readout as being correct if it is within 200 feet of the level reported. To ascertain the accuracy, you may also hear the phrase verify your level or check altimeter setting and report level. Golf Victor, check altimeter setting and report level.
1013, flight level 50, Golf Victor.
As we touched upon just now, certain special purpose codes are in use. These are 7700 to indicate an emergency, 7600 to indicate communications failure, 7500 to indicate that the aircraft is subject to unlawful interference. 2000 is used when entering the UK FIR from an adjacent region where the operation of transponders has not been required. Additionally, in the UK we have a conspicuity code, 7000. All suitably equipped aircraft should display the conspicuity code together with Mode Charlie unless they have been assigned a discrete code by an air traffic control unit, They're flying in the aerodrome pattern below 3,000 feet, or they're transponding one of the special purpose codes. Subject to the above, pilots are required to squawk 7,000 when operating at flight level 100 and above, and are advised to do so when operating below flight level 100. When changing the code setting on a transponder, it's recommended that you first switch the function to standby before changing the numbers. This is so that there's no danger of inadvertently triggering one of the special purpose codes.
End of Disc 3.